This is the trick. T equals 18 months. Because the formula specifically says the time has to be in years. So the accumulated value equals PE to RT. P equals 10,000. E is Euler's number, 0.041. And now I have to be very careful because I have to change 18 months, which is 1 year, 12 months, and another 6 months into years. So what will that be?
$1.5.
Very good. Indeed, 1.5. All I have to do is plug in the graphing calculator. No one can do this by hand. Okay, let's clear this. You know me, I like to put the function in. You don't have to, it's just one, but I like to, that's me, I like to see the function. I want to make sure that I entered it correctly, yada, yada. So, I don't have to, honestly, for this one, because I would just put x in there as t. That's okay. We only have one. So 10,000 second E. You know my parentheses. I'm in love with my parentheses. 0.041 multiplied by 1.5. The reason is that I don't know what calculator you have. This calculator that I have here, it will work without parentheses for the power, but I want to be on the safe side. And I also like to use my parentheses. Okay, so 10,634, since we're talking about money, 0.30. Okay, back to my book. Okay. So we know how to punch in natural log. You just punch in a natural log 2. Oh, I can show that. Let's say natural log of 0.103. All you have to do is activate natural log 0.103. I think it was. It doesn't matter. Just press enter. That's it. Okay, back to the book. Let's go to the next page. Okay, so one thing that I would like to refresh your memory on these equations, but before we look at these equations and then the domain of log and solving log equations as well, I'd like to present the most important, very, very important relationship. Any log equation can be turned into or replaced by an exponential equation and vice versa. So here's a log equation. Log base A of x is y. Any log equation, log base A of x is y, is equivalent to, this is the double equivalency that includes the vice versa. This will imply this will imply this. Here's how we do it. The base raised to this power equals this number. Base raised to y equals x. This is the most important concept, I would say, in this chapter. A raised to y equals x. Okay. So now let's take a look. Let's choose, I'm sharing my screen. Let's choose solve for t. Anything you like to choose from 39 through 50. If you don't, I will.
47.
Which one?
47.
47. So 47 on page 204. 47. I have 5e to 2t equals 15. Perfect pick. Okay. So I always tell my students, factor, simplify. If you like, clean it up. Clean it up. Is there anything I can do here to clean it up? Any thoughts?
Divide 5.
Divide both sides by 5. That's a big thing because it's multiplied. So divide this by 5, divide this by 5. So e to 2t equals 3. Now, there is only one function. Remember, we had square root of x plus 1 equals 2. And I applied an operator. This is the operator I applied to solve. Which operator I have to apply to both sides to solve this equation?
Ln.
Very good. Specifically ln because the base is e. Can I use any other log? Yes, I can. The answer will be the same. But why? The easiest thing to apply is the inverse function of this. Then I have to apply it here as well. If I apply it to the left, I have to apply it to the right. I cannot just pick and choose. Good. So if that's the case, the property that we just discussed is this. Goes in front as a factor, multiplied. So 2t natural log e equals natural log 3. Now we have to remember this forever. How much is natural log e? Let's say I have no idea. Very easy. Natural log e. I have to remember this forever. 1. So it's 1. So this goes away. So I have 2t equals natural log 3. And what is the final answer for t? What do we need to do to both sides to get t?
Sorry, 3 over 2.
Yes. Natural log 3, everything over 2. I'm not saying you said that, but if you rewrite it like this is incorrect. We are dividing this number by this number. Perfect. Okay, let's move on. Where is my book? Here's my book. Okay, so let's find a domain. Any problem you would like to look at for the domain of the log? Very important. Anyone?
58.
A log to sorry. So I'm not sure, Lyndon. So what do I do with this, or what was the question?
It wasn't a question. It was just something my old professor had said when we were
Okay.
to log the exponent.
Whatever works, I'm for it.
Just an acronym.
That's fine. So sorry, I talked and I didn't hear what you said. Which problem are we working on?
58.
58. In 58, we have g of x, natural log of x plus 6, and plus natural log x. And that is find a domain. Perfect. I'm going back to what we wrote here when we graphed. So let's look for a second at e to the x. Can anyone give us the domain for e to the x?
Negative infinity to infinity.
Awesome. Excellent. Thank you. Can anyone give us the range for e to the x? It's okay if you're wrong. 0 to infinity. Very good. So keep that in mind for a second. I'll go back here. So we said that the exponential function, colon, so this is the function. Here will be the domain. You gave me the domain. And the arrow and the range. So you said 0 to infinity. Awesome. So any exponential function is defined on negative infinity to infinity, taking values or range on 0 to infinity. Knowing that the exponential function and the log function are inverses of each other, can anyone give us now the range and the domain for the log? What is the domain of the log?
From 0 to positive infinity.
Excellent. Can anyone give us the range?
Negative infinity and positive infinity.
Of course. That's the whole thing. That's exactly why they are inverses of each other. Absolutely. 0 to infinity and the range negative infinity to infinity. What is the point I'm making here? I'm making a point, trouble. That's my point. So the exponential function, I call it friendly. I don't have to worry about it, but I do have to worry about the log. It cannot be applied to 0, and it cannot be applied to negative numbers. So that's the problem here. So let's go back to this function and then to this function, because this one is the sum of two functions. Both have to exist at the same time. What condition would you write for this, and what condition would you write for this? And I'll put them here.
Greater than or equal to 0. Oh, just greater than 0.
But I don't know what. You haven't told me yet.
Is it x? Oh, x plus 6.
Exactly, because natural log is applied to x plus 6. It's like, for example, the square of x plus 6. Do I write x greater than 0 or equal to in this case? No. I write this. Good. And for the other one?
X greater than 0.
That's it. So now I have to solve the system. This one says greater than negative 6. This one says greater than 0. I have to find the common or the intersection, because I'm talking about this function. Nobody cares about this. Nobody cares about this. We care about the domain of this function. So when I draw the real line, for greater than negative 6, I have this. I don't need units. And for greater than 0, I have this. I need both conditions to be fulfilled at the same time. So, what is the domain of the entire function?
0 to infinity.
Of course, that's where both colors are. Green and orange have to be there at the same time. This, only one function exists, and here, none of the above. That's how we determine the domain. So let's look at a log equation and then application. Yes?
I get lost. I don't know how.
Say it again.
I get lost over there.
Which one?
How the x plus 6
Tess, can you say it again? I couldn't hear you.
no, where we get the x plus 6?
Natural log has to be applied to a positive number. Natural log has to be applied to a positive number.
No, we're gonna take only that inside one? Okay.
That's what log is applied to. I cannot invent anything. I cannot add or subtract anything. Log has to be applied to a positive number. This log has to be applied to a positive number. Is that better?
Okay, yeah.
Perfect. Anyone else has question here? Anything else?
So that's the domain restriction for logs, and then exponents doesn't have one.
What do you mean next one?
No, I was saying that's the domain restriction for like all logs.
Any log can be applied only to positive numbers. And the range will be anything. Better? So keep this in mind. This function is like the square root. It needs restrictions. And also like a rational function that cannot have 0 in the denominator. So these three functions are trouble. Square root or any even root, log, and rational. They are not friendly. Okay. Let's move on to a log equation and then a word problem.